Can you sleep after a concussion? Hey guys, my name is Dr. Cameron Marshall. I'm the founder and current CEO of Complete Concussions, which is the largest concussion care network in the world. I'm also a published concussion researcher, and I've trained tens of thousands of people on how to manage concussions properly. So this video is a common question that we get all the time. Can you sleep after a concussion? Well, today, the first thing I want to talk about is what is a concussion. Once we understand that, we can understand why people might think this and actually what the new recommendations are. So concussion is a brain injury that's due to acceleration and deceleration. We used to think it was the brain smashing against the skull and bouncing back and causing a bruising on the brain. What we now know is that it's actually stretching of the brain cells underneath. And so if we watch this little GIF here, we can see that as the brain gets impacted, there's this fluid wave that happens. And if you imagine each of the cells of the brain being these long kind of tubular structures like strands, as that brain goes through that kind of fluid wave, each of those strands is getting stretched. But not only that, because the brain is actually two different tissue density layers. We have the white matter, which is deep down here, and then we have the gray matter, which is on the outside. The white matter is lined with myelin, which is a fat. The outside of the part of the brain, the gray matter, is not. And so they're two different densities, which means they accelerate and decelerate at different rates. So you're going to get this stretching, but also those two layers are, because they accelerate and decelerate at different rates, they're kind of going to get sheared across each other. Not to the point of breaking. And in fact, if we look at an MRI after concussion, we don't see any observable damage to the brain. The brain structure remains intact, which means that this is a functional injury, not a structural injury, which is why most imaging is normal after a concussion injury. You can't see a concussion on an MRI or a CT scan. There's two phases to this injury. It's a functional injury, means it changes how the brain cells function for a period of time. There's two phases. The first phase is called the excitation phase, and the second phase is called spreading depression. I'm going to go through each one of these right now. So the brain cells, like I mentioned, are these kind of long tubular structures, right? So if we picture this long tube, right? Now, inside the brain cell, there's different molecules, and outside the brain cell, there's other molecules. So inside the brain cell, there's large amounts of potassium, and on the outside of the brain cell, there's small amounts of potassium. So this forms something called a concentration gradient, meaning that things tend to want to dissolve and move away from itself. It wants to evenly distribute. So if there's a large amount or a large concentration of potassium inside of a brain cell and a smaller amount on the outside, potassium naturally wants to go where there's less of itself. This means moving down its concentration gradient. So there's a drive, a natural drive for potassium to want to leave the cell. Now we also have high amounts of calcium and high amounts of sodium outside the cell and lower amounts inside, which means that the drive, the natural drive, is for sodium to want to get into the cell and calcium to want to get into the cell. So these are long tubular axons. Now, we can think of it like this, where it's not actually a solid tube, but there's little tiny pores throughout it, right? Just like your skin has pores, there's pores here, right? Generally, it forms a natural barrier, but you can still have things come through those pores, like sweat, for example. Now, this is a brain cell at a resting state. When that acceleration happens, this brain cell gets stretched, and now those pores actually get stretched open quickly. And in that split second that they get stretched and come back together, what's going to happen? Well, potassium is going to leave and sodium and calcium are going to come rushing in. This changes the composition of the cell, which makes it excited, and then it goes through something called an action potential. Action potentials are normal. So you listening to me right now and seeing me on camera, all of that is causing the nerve cells in your brain to fire, but it's all happening in an organized way. So you're having these action potentials, things are going into the right spot so that you can interpret what I'm saying. It's passing signals from cell to cell so you might be able to store it as memories and other things like that. In a concussion, this happens to millions of cells that are not part of the same network, and so everything happens in this haphazard way. So you get this millions of brain cells all firing at the same time. This might cause someone to go unconscious. It may cause someone to lose balance. It may cause someone to be confused or disoriented. It may cause someone to see stars, right? It's all just random electrical impulses that don't make any sense, so your brain can't really make sense of the world around it. This process usually lasts only a few seconds to a few minutes. Generally, if you've ever been around somebody that's got a concussion, you see a game or something, they get hit, they stand up, they're wobbly, they're off balance, and then they kind of go, okay, there's the ball, I'm going that way. And they kind of come to a little bit. So this is all it is. That first phase is the excitation phase, very short duration. This is kind of what it looks like here. So you have depolarization and action potentials. Those action potentials cause neurotransmitters to be released that are excitatory, meaning it causes the next neuron in the chain to also become excited. So this is glutamate here. So glutamate goes and attaches to these NMDA receptors. Remember, calcium already wants in. These NMDA receptor bindings allow calcium to come in at an even greater rate. Calcium is a problem. Calcium gets into our mitochondria and prevents us from being able to produce energy. So the energy molecule that we create in our bodies is called ATP. And this is responsible for all sorts of processes in our body, but a lot of it is used by our brain, and it's produced by the mitochondria. So when you eat food and breathe oxygen, all of that is translated in the mitochondria to produce ATP. Now, ATP is used to reset the ion balance. Remember, we said potassium leaves and sodium and calcium come rushing in when a concussion happens? Well, we have these little pumps called sodium-potassium pumps, and they try to reset the balance. They try to pump potassium back in against the concentration gradient, and they try to get sodium out. But that requires energy. So we need ATP to do that process to reset the balance inside our axons. So that requires ATP. So we have an increased need for ATP after a concussion injury, but calcium gets into our mitochondria and basically makes it so that we can't produce ATP. So we have this massive drop in production while we need more to reset the balance in our brains to be able to function properly. So what you get is an energy crisis. And this is the second phase, which is called spreading depression. Now, this is in an animal model. So you can see ATP here. This is a group with no concussion. This is 1 minute after concussion, 10 minutes after concussion, 30 minutes after concussion, 2 hours, 6 hours. Now, this is in an animal. In humans, right? Or sorry, I should just finish this. But in mice, you get back up to this level at 120 hours. You see that star has disappeared, meaning no more significant difference, meaning that basically the recovery in a mouse after concussion is about 5 days. Now, humans go through the same process. However, the recovery, see this single star, 22 days later, still not there yet. But by day 30, the brain has recovered after a concussion injury. So it's a short-term, 3 to 4 week process that results in a drop in ATP levels. And you can't see it on imaging, so there's no kind of structural damage to the brain, which is why this is confusing for many people, because it feels like my brain isn't working properly. And why is it, right? You can't see it on imaging or anything like that. So what you can imagine, though, is as that ATP level is dropped, the person's going to be very tired. They're going to have fatigue. They don't have energy to sustain the things they need to do. They're not going to be able to think properly. They're not going to be able to exercise properly. They're not going to have any energy at all. So sleep is actually good for concussion recovery, okay? Sleep is good, but the concern in the acute phases, meaning within the first few hours after a concussion, and why people are told not to sleep is not because of the concussion at all. It's because we're concerned that something more serious may have occurred. Something like a brain bleed. So this is what imaging can see. This is why if you go to the hospital after a concussion injury, depending on the symptoms you have, they may do a CT scan. And that CT scan is not to look for concussion because it can't see it. It's to look for the presence of a bleed. So you can see here there's some different types of bleeds. You have epidural and subdural hematomas, and you can kind of see how this is putting pressure on the brain. Now that's going to start to cause some telltale signs. This is what it's called red flags. So these are the things we want to be watching for after a concussion injury, because if they are present, we want to go to the hospital to get a CT scan to make sure that we don't have a bleed in our brain. So sleep has nothing to do with the concussion injury, but if you've had a head impact, potentially, you've also damaged some blood vessels in the brain, which are now bleeding, and you might not know it. So if the person goes to sleep, we can't monitor to see whether they're getting worse or not. And that's the concern. Somebody goes to sleep and they don't wake up in the morning because overnight they've been bleeding. And that is obviously a bad thing. So the things we want to look for are are called red flags. So these are the things that if these are present, you need to go to the emergency department ASAP, okay? Now these generally appear within 4 hours after injury. Neck pain or tenderness, this is to do more with a neck fracture than a bleed. Seizures or convulsions, experiencing double vision, which can be common, but if it's been a few hours and the person's still experiencing double vision, ER. Loss of consciousness, again, this should be longer than 30 minutes, not just any loss of consciousness, but it's generally longer than 30 minutes. Weakness or tingling or burning in more than one arm or leg, that is generally due more to spinal cord damage than anything. Deteriorating conscious state, vomiting, or mostly repeated vomiting. So if the person vomits twice or more, you should be definitely taking them. Severe or increasing headache, right? Because if you're getting a bleed, that's putting pressure on the brain. The headache's getting worse and worse and worse. ER. Increasingly restless, agitated, or combative. A Glasgow Coma Scale less than 15. The most common one you'll see here is confusion. It's normal to have an immediate sense of confusion, but if the person is still confused a few hours after the injury, you should go to the hospital. If the person keeps asking you the same questions like, what happened? Why am I here? Why do I feel like this? And then you tell them, and then 5 minutes later they're going, what happened? Why am I here? Why do I feel like this? They're having post-traumatic amnesia. If that's still happening 2 hours after the injury, go to the hospital. Or any visible deformity of the skull. Potentially they have a skull fracture, right? So if you feel around to their head and there's a soft spot, hospital. Because there's a fracture, there's a high chance that there's also a bleed, okay? This generally, like I said, appears within 4 hours after the injury. So how should we think about this? Well, any head trauma needs to be left in the care of a responsible adult. We can't just send these people home. Even if they themselves are an adult and you've witnessed them get a head trauma, make sure they're with their spouse, make sure their spouse knows about the issue, make sure that they're with a family member who's responsible that can actually monitor them for any of these red flags and signs of worsening condition. And then what I always say is no sleep for at least 4 hours because we want to be able to monitor for these signs of deterioration. If the person gets home after their game and they just go right to sleep, we're not able to monitor them. We can't talk to them. We can't have them stand. We can't look at their balance. We can't ask them if they're having, pain and increasing in their head or any of these other things. So we need to be able to monitor them. So I say keep them awake for at least 4 hours. But after 4 hours, you can let them sleep. Now, the old rule used to be wake them up every 1 to 2 hours overnight. And that was, again, just because, not because of the concussion, but because of the potential for a bleed. I personally, if it was my kid, I would still do this. Now, what they say is that we shouldn't do this because sleep is so important for concussion recovery. Now, the research on this shows that by having some element of sleep disruption in the first night does not harm recovery at all. So in my mind, I would rather err on the side of caution and wake the person up every 1 to 2 hours throughout that first night just to be sure. I've heard of cases where people get a head injury, they go to sleep, they wake up in the morning and then collapse. And die because of a bleed. So it can happen, it can be delayed, it's more rare, but I would say, personally, I would err on the side of caution with this, and I would check on them every 1 to 2 hours. Now, you don't necessarily have to wake them up. If you go in and they're breathing normally and everything sounds good, you can probably just leave them. Or you could wake them up, but all you're trying to see is, can I wake them up? If I go to, give them a little shake and they go, what? What's going on? What's going on? You just go back to sleep. That's it. You just want to make sure you can wake them up. Because if you go to rouse them and it's been an hour and they're not waking up, well, maybe now you can sound the emergency alarm and get, help for that person. So it is considered outdated. If you look online, it'll tell you, let the person sleep. Personally, I've just heard of some really tragic stories, and so I would do it if it was my, son, daughter, mother, father. So the goal is to make sure that they're breathing normally and to make sure that they can be aroused. So that's it. So can we sleep after concussion? The answer is yes. I would give it at least 4 hours. Monitor for those red flags. If you're at all concerned, go to the hospital. They'll check you out. They'll see if you need a CT scan or not. Now, share this video with somebody and hopefully it saves a life.